Hello everyone. Here we are gathered for a ISC2 activity for PPT presentation of processor architecture, and I am Hemant Shashikant Yadav, studying in SY CSE class B and division B, and today I am here for explaining a topic of what is subroutine, examples of subroutine, and about subroutine. Let us start the topic. So first, what is subroutine? Subroutine is a program that is we use repeatedly and that are used by the main program to perform a specific task, and we can call the subroutine in many times in a microprocessor. So we do not have to repeat the program again and again. We define the program in another memory location, and we just call the address of the this is the structure of subroutine, where a mainline program is there, which is the calling program, also called as calling program, and there is a procedure call. So when the call procedure is executed, the program flow is diverted from main program to the subroutine program. That after performing subroutine task, when the return instruction is performed, the flow of program will again return back to the mainline program, and the instruction after the mainline programs are executed. So there are two instructions under subroutine: call instruction and return instruction. In call instruction, there are two types of call instruction: unconditional call and conditional call. And in return instruction also there is two instructions: unconditional return and conditional return. So what is the execution of call instruction? How call instruction is executed? So for call instruction, we have to first determine the stack or stack area or stack before the call instruction. The stack, the syntax of stack is stack and 16-bit address in 8085. After determining the stack position, we determine the call instruction, and in that call instruction, the syntax of call instruction is call and 16-bit address. That 16-bit address is of first address in subroutine program. So after that, when we execute the call instruction, the stack pointer is decremented by 1, and the next instruction, the address of next instruction is always present in program counter. That address from program counter is stored at the stack, and the program counter is loaded with the call instruction address, which is also the subroutine address. And in return instruction, when our whole call instruction or subroutine program is executed, there is a return instruction which returns the flow of program to the main program. So in return instruction, there is no parameters are required. It is just 1 byte instruction, and after when this instruction is executed, the data from the stack pointer, stack memory location, which is the address of next instruction after the call instruction. After call instruction, there the address of next instruction in main program, which is stored in the stack, is retrieved again, and that address is stored in a program counter. And when that address is executed, the flow of program is diverted to the mainline program from the from subroutine program. So let us see the examples regarding the subroutine. So in the first, we will see the call instruction example. So here at 2000 memory location, there is call instruction, that is call 5000. So this 2000 location is of main negative program. So at the main memory at 2000 place there is call instruction, and the 5000 is the location of the subroutine program. So at the flow of program will flow from 2000 to 5000. So when the call, so before that call instruction, we have to declare the stack memory location. So here we have declared the stack memory location as SP FFFF. So here the stack memory location is declared. So when we execute the call instruction as call 5000, so stack pointer is decremented by 1 and the higher byte order address, that is 20, is stored at stack pointer, and after that stack pointer again decremented by 1 and the remaining lower byte address is stored at the FFFD instruction from program counter. This address is the next address after the call instruction. So the next address of the call after call instruction is stored at the stack pointer, and the program, the flow of program will flow from 2000 to 5000. And when we reach at the return instruction, so here as we see that 1 to F1 is call instruction, 1 to F2 we have called the call instruction, and the flow is flowed from 1 to F2 to 1 to C200. So the flow is flowed from this, and this, the next memory location 1 to F3 is stored at that stored at this stack pointer. So when we execute the all processing subroutine, we reach at the return instruction. So when we call the return instruction, the data from the stack pointer, the stack pointer is the data from stack pointer, that is F3, is copied to the E register by default, and it is decremented by 1. And after that 1 to that higher order address is copied to the D register, and the stack pointer is again incremented by 1. So after that address is stored at the program counter, and that 1 to F3 address is executed, and the flow of program is returned from subroutine program to the main program. So this is another example. So at LXI SX99 we have declared the stack memory location, and at XX09 we have call instruction, and after that there is a 50 which is lower byte address, and XX is higher byte address of the subroutine program. So we have taken that address and the call instruction. So and we reach that the call instruction, we execute that the subroutine program, and when we reach at return position, we again went to the main program and executed main program. So what is the conclusion? The subroutine program decomposes the main program into smaller chunk of parts. It reduces the duplication of program. So if there is no subroutine, we have to declare one program again and again if we want to execute it. And if we created a subroutine, so we can just call it whenever we want, and just we will declare it at once, and enabling the reuse. As we said, we can call subroutine again and again whenever we want, and improving the traceability. So if one function is there and we have created a step at separate location, so we don't need to traverse all the main program to get the that particular function, and make the debugging of program easy. If there is any debugging went by instruction by instruction. So for many programs we have created the subroutine, so we can access each program instruction by instruction if we have created subroutine. So that is it, and I thank you all for listening this video presentation.